inch. Okay? The next position, the third position, this is the welding position. So 1 means all positions. Number 2 means horizontal and flat. 3 is not currently used at all. And 4 means vertical down. So you're not going to see a lot of 4. Okay? So if you see all positions, it can be, let's do 60-10 and 70-18, okay? So 60-10 is a 1, 70-1-8, they're both 1. So they're both all position rods. Okay, start there. That does not mean that they can both be run downhill. Okay, so that's what we call progression, not position. Position is considered to be flat, horizontal, vertical, or overhead. Okay? So overhead doesn't necessarily have to mean, at the same time, overhead doesn't mean it has to be over your head. It's still the same position, what we call a number 4 position. In the case of a fillet weld, it would be a 4F position. And it can be the 4F overhead position 3 inches off the ground or 3 miles in the air. Doesn't matter, it's still the same welding position. It does not have to be over your head. For example, pipeline welders, API code says you have to have 16 inches from ground to the bottom of the pipe. Let me tell you what, 16 is hard to come by some days. A lot of days you get 10 or 12, okay? So, again, it's still an overhead weld. It's not above your head. It's still the same weld. It's the position, not necessarily where it's at in relation to your physical position at the weld, your physical spot that you're looking at it, okay? So, back to 60-10, all position. It can be welded uphill progression. It can also be welded downhill. It was mainly designed for a downhill pipe welding, okay? However, it was designed for downhill. It's also used for uphill welding. Originally it was 60-10, now they've come out with a 5P for a higher penetrating rod. The 5P has characteristics to be uphill and downhill progression. So it's a vertical position with an uphill progression or a downhill progression. Now 70-18 can only be welded uphill. 70-18 is not welded downhill. Just like anything else, you're going to find a company that's going to make a specialty rare rod that can be welded. So for example, there is a 70-18 welding rod that can be welded downhill. However, don't do it. All other 70-18 welding rods are designed to be welded uphill. I would not start the habit of welding downhill with 70-18 unless you specifically bought the box, it was unopened, and it says designed for downhill welding only. Okay? 70-18, uphill progression in a vertical manner. Now overhead, it doesn't matter because it's not uphill or downhill, right? Horizontal. A horizontal welding position, we're going to weld straight across this. The position based on the welding axis, the axis of the weld itself. Not the vertical plane, but the horizontal weld axis, okay? Just wanted to clarify a few things about positions and then progression, whether it be uphill or downhill as well. All right. The fourth position, this is the type of covering, type of welding current. It can show a lot of things in there. We talked about here in the book, it tells you, if you look at it, type of covering and type of welding current. Some operating characteristics as well, so forth. So for example, the 8 we know is a low hydrogen iron powder. If we look back, I believe 70-15 is a low hydrogen, but it's a sodium coating, okay? And then 70-16 is also a low hydrogen, but it's a potassium alloying element instead of the iron powder. All right. Optional. This meets military requirements, greater toughness, lower moisture content, and mandatory diffusible hydrogen limits. Okay? For most welding materials that we're going to see, you will not need to have this. If you go to a job that specs it, make sure you talk to your supply warehouse, your rod supplier, and make sure that you're getting military grade materials on that as well. I've hardly run into anything that was a M designation on the back of it, okay? Designates electrode has improved toughness. So now let's go through this and we'll read back through the book. Optional supplement for hydrogen designator. And this is optional absorbed moisture test for low hydrogen electrodes. So, trying to find a good example here out of your book to be able to explain to you. Let's go to the book and let's read from it, page 314, chapter 12. The many types underneath the AWS classification of carbon steel electrodes. The many types of electrodes that are available to weld carbon low alloy steels are classified in the AWS filler specs 8.5.1 and 5.5. These booklets can be purchased from the American Welding Society. Other agencies are as follows. Okay, skip down to below the bullet points, start out the various electrodes are classified with the system of numbers and organized on the basis of the chemical composition and mechanical properties of the deposited undiluted weld metal, type of covering, welding position, type of current required for best results. Compare the various characteristics of carbon steel electrodes in tables 12.3, 12.4, pages 312 to 313. You can read through that. We basically just discussed going from there. Okay. Let's read down through this section. Look at table 12-7, the interpretation of the last digit. So as I'm doing this, I'm trying to make sure that you can find a place in the book to help reference it as well if you miss a spot during our conversation. You can always come back to the PowerPoint here as well. So we're on page 316 under electrode selection. The selection of the proper electrode for a given welding job is one of the most important decisions that the welder faces. We talked about this in chapter 11, matching your base metal and your filler metal together to make sure that their mechanical properties and physical properties are compatible. Okay. Skip down to the end of that paragraph. It says electrodes may be generally grouped according to 3 bolded points of operating characteristics, type of covering, characteristics of deposited metal. Okay? Size is also an important consideration. So this is a big one as well. This is a bulleted point. Size is also an important consideration. Page 316, chapter 12. It is important to understand that many electrode classifications contain the same basic core wire. The differences in operating characteristics and the physical and mechanical nature of the deposited weld bead or weld metal are mostly determined by the materials in the covering. You are urged to study carefully the characteristics of the basic welding electrodes described in this section. A thorough knowledge will assist you not only in acquiring the technical knowledge necessary to choose the proper electrode for a given job, but also in mastering the manipulative techniques of the welding operation. As we have seen, there's a large number of electrodes that can be selected. In order to reduce the number of tests the welder has to take to become qualified, or in parentheses certified, many codes group electrodes based on their ease of welding rather than on mechanical properties. One such grouping is from the AWS D1.1 Structural Welding Code of Steel. If any of the electrodes in the more difficult 4F, F4 grouping is used on the welder qualification test, A welder who passes the test will be qualified on all the electrodes in this group, as well as on any lesser group numbers and the electrodes they represent. So, we read that part out of the book, and the reason I wanted to read it is to tell you that's not always the case. AWS, certain procedures will accept that. Most procedures will not. Okay, so for example, 6010 and 7018. 6010 is of an F3 group, 7018 is an F4 group, stating that it should be a harder electrode to weld. Okay, so what they're saying in that paragraph is that if you can weld in 7018, you're qualified to weld in 6010. Absolutely not. The welding procedure itself, if you change on the procedure itself, if you change the electrode group or classification a lot of times, then you have to rewrite the procedure. It's a different one. However, there are certain procedures, say it's going to be a 6010 and 7018 for a rut pass, hot pass, and then filler passes and a cover pass. Okay, so it might be 6010 for the first two weld passes, 7018 for the rest. So in that case, you're covered for both materials. So you can have more than one electrode on a procedure. However, if the electrode is not on the procedure, so if it's 7018 and you qualify under 7018, it does not qualify you to, or certify you to go to weld 6010. It's a different electrode, a different procedure. There are a couple pre-qualifieds that the AWS would allow that to happen. However, the majority of the world says no. It's a variable that's non-constant. Okay? All right. So I just wanted to talk about that because a lot of people are confused when they read that section. They go out and they think that that's the way that it's used in common practice, and it's not. So we're at, as far as for test purposes, that's what it's telling you here. But I am telling you, when you get out there, it is not the real world. As a certified welding inspector for the AWS, I write a lot of welding certifications. I read a lot of procedures. I've proven some PQRs, and I've been through the training, and I've got all the qualifications, and my testing and certification prove that I know what I'm talking about. And it's kind of crazy that this book still has this, especially being an AWS endorsed book, because this is not true. This is not the case. Okay? Okay, as important as selecting the right classification of electrode comes joint design, material thickness. So we're looking at the bullet points off the 316, page 316, chapter 12, left-hand column at the very bottom of the page, underneath size of electrodes. The bullet points start out saying joint design. The fillet weld can be welded with a larger electrode than an open groove weld. Yes. However, you still need to make sure that you're getting full rut penetration and breaking down both pieces of material that you're welding. Okay? So don't think that if it's a 1/8 inch piece of material, you're going to weld it with a 1/4 inch electrode at 260 amps. Number one, everything will melt and fall apart, but you're going to have some other issues as well. Okay? Material thickness. Larger electrode used as thickness of material increases. And that's somewhat true. One thing that's also confusing is that a lot of welding machines will be rated, if you look at them, they're going to be rated for 1/4 inch steel. That's what you're going to see. Okay? This machine can weld, especially for most home machines, which there are a lot of the questions we get here in the shop, or I get. So it might tell you that it can weld 1/4 inch plate, 200 amp machine, okay? So what this is telling you is this is going to weld it, and that's what it can weld. That's its max. One pass. One pass. That does not mean what we do here in the shop. Most of these weld passes are not 1/4 inch at one time. Okay? And if we're going to run an 1/8 inch electrode to control heat, we're only at 120 amps as it is. 105 to 135, right? Okay, so we're only half of that. So at that case, we only expect to weld half of it as well. You don't have to weld this all at once, okay? You don't have to do a 1/4 inch weld at one time. You do as many weld passes to maintain a quality weld as needed. Okay, so when you're looking at a machine that says it can do a 1/4 inch plate, that's in one pass. Look at your amp rating. You're starting to know and see, or your voltage rating. Okay, you're starting to understand, say it'll weld 24 volts. And in the shop we run 035 wire, and we're going to run, you know, between 17 and 20 volts. So again, we're less voltage than what the machine's calling for. It's just important to know that when you're looking at this, this is one pass is what they're saying, it's max capability. However, you can always step it down, do multiple passes in between. More weld material deposited in flat and horizontal positions than in vertical and overhead. And that's true. I don't know about the vertical, but in flat, you can definitely put down a lot more material. There's also a lot less chance, a reduced chance, I should say, a reduced chance of trapping discontinuities and impurities as you're doing it flat than there is in the other positions. And the way that the code reads it as well is, so flat would be your easiest position. So one position, 1G, 1F. The number 2 position is going to be your horizontal. Whether it be a 2F or a 2G, fillet weld or a groove weld. That's your horizontal. That's the next hardest position. And then your 3, which is a vertical. Again, vertical can be uphill or a downhill progression. That doesn't matter. It's 3 position, 3F or 3G, 3 fillet weld or a groove weld. Okay? That's the vertical. And then 4F or 4G is the overhead position. And that's considered to be the hardest. So a lot of codes will say if you can weld in a 3 and a 4G or a 4F position, then you're qualified for a 1, 2, 3, and 4. You're qualified to weld in all positions. However, if you only certify or qualify for a flat and horizontal, you're only allowed to weld in the flat and horizontal. If you do it in flat, you're only allowed to weld or certified to weld in a flat position only for that type of weld, a groove or a fillet. I'll say we do a number 3 and a number 4 groove weld, and you pass your certification, then you're qualified to weld in all positions, 1, 2, 3, and 4 position in both fillet and groove weld, because a groove weld is harder than a fillet weld. See how we're starting to kind of supersede certain portions, and that's the way the code looks at it. If you can do the easier positions, then if you can do the harder positions, then you're qualified for the easier positions. So we start with flat and horizontal, move on to the harder positions as well. Welding position, a larger size electrode can be used in flat and horizontal than in vertical and overhead positions. And that's true, that's heat input, that's liquid manipulation as well. The amount of the current, higher the current value, the larger the electrode, the skill of the welder. For sure, about the first time you try to do overhead, you will understand the skill of the welder portion. And sometimes there's some physical characteristics that are tough for us as well. You know, people with limited mobility. Say you've got a back injury or a neck injury, it might be hard for you to do an overhead weld. In that case, we need to see what we can do to help accommodate, make you comfortable, because we're still going to have to do the overhead welds. Okay? At that point, come and get me. We'll talk about it. See how we can set it up to accommodate you, and try to keep the strain and the stress off your back or your neck or so forth, okay? All right. So, here we talk about electrode classifications for multi-pass welding. Okay. This is under page 316, chapter 12, right-hand column, about halfway down. So all classes of covered electrodes are designed for multiple pass welding. We call it multi-pass. The size varies with the types of joints and welding position. So you can read through the bolded items there. Also here, I'm just going to touch on them a second. The one thing you have to be very careful of is the larger the size you get. So 1/8 inch, especially welding vertical and overhead, 1/8 inch, especially starting out, 1/8 inch is max. As you gain skill and experience, then we'll go to 532. We don't run 532 here in the shop. We have a few just for an example to be able to try them as you're getting through the program later and later. 332 or 1/8 inch, vertical and overhead. Okay, we're trying to set us up for success. Again, let's learn how to control and weld with the easier electrodes to manipulate and weld with than before we jump into the large ones with a large amount of heat input, creating problems for ourselves and becoming very frustrated. We're trying to set ourselves up for success. Okay, 332 and 1/8 inch vertical and overhead is where we're going to stick at. By the time you, 1/4 inch electrode, you're running 260, 270 amps. We used to run that, that's shipbuilding. Let's stick 1-2 inch material, and that's a tremendous amount of heat input into that. So the distortion alone is pretty incredible. When you're welding with a 1/4 inch electrode, usually you're making sure that you're preheating and you're maintaining a 300 to 400 degree preheat to start with. It's keeping the molecules out there so you're not shocking the molecules in the system and putting stress and strain on the grain structure. Okay? So 332 and 1/8 inch is what we're concerned with. In our program here, if you can learn to weld those as your experience gets better, your skill level gets better, then you can expand into larger electrode diameters. If you look on page 317, table 12-8, pretty good table about its relative ratings of factors affecting the preliminary selection of electrodes. Okay, just something to look over. All right, so job requirements. Now we're talking about variables, okay? Right here, right off the bat. There's not only one way to weld a material. As the variables, essential variables change, or many variables change, we have to evaluate and change as well, okay? Now there's a lot of mainstream techniques that we're going to show, I will show you, that I've found have worked to kind of cover a broad range of variables, okay? And that's partially why I teach the techniques that I do as I'm welding, because overall they're good techniques.